All right, let's talk about the quizzes from Wednesday. So some of these questions kind of gave you guys a hard time. So the range is the y values. You can see here that these two lines connect and then this line continues down. So this range is going to be the flat line and then all the values below it. So the flat line is at 1, 2, 3, 4. So the y values are going to be y less than or equal to 4. So remember, a bracket means equal, and then negative infinity means, extending down all the way to the end. The domain. The domain is the x values. As long as all the bits and pieces of the graphs match in here, the domain is all reals. So negative to positive infinity. Once again, two graphs meet up, domains, all reals. The range, this one's going down, this one's going up, and across, so it's horizontal, so it's our highest point, so it's from 1 and down. So negative infinity to 1, it includes 1, so it gets a bracket. Domain, matches, 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 all reals, negative infinity to infinity. Remember, the infinities always have parentheses. Do not give me brackets if you write the domain like this. The range, going up, going up. Highest points are way up at the infinities. Lowest point is down here at -2. So it's going to be -2 to infinity, once again, including -2. Domain. So this value is from -1 and to the left. This one picks up at 3 and goes to the right. So since they don't meet, it's -1 and all the values less, +3 and all the values greater. So it's negative infinity to -1. The U just means union or connecting, and then 3 to positive infinity. This graph is going up and includes -1. This graph is at -1. They're kind of doubly included, so the range is all the values from -1 to positive infinity. This graph matches to that graph, so all reals so far. This one jumps straight down to this graph. This one's closed, this one's open. Once again, they match. This one's going on forever, so the domain is all reals. This passes the vertical line test because it's closed to open. The range, this one's going up, so it's all the y values greater than -2. Then we have a jump down here to this point at -4. So it's, -5. So it's not including -5 because this point is open. So it's negative infinity to -5, not including -5. And then this is closed, so it's -2 to infinity. These two match up, even though it goes closed to open, passes the vertical line test, all reals. Closed to open, so it's these values and less than, so -2 all the way down, so negative infinity to -2, jumps all the way up to 3, but doesn't include 3, to infinity, so bracket at -2 because it's closed, parentheses at 3 because it's open. What is the domain restriction? So that's kind of like, hey, can you see what we're doing today? So it is going to be from 0 and on, including 0 because it's closed. So x greater than or equal to 0. All right. Hopefully that helped you better understand piecewise functions and their domains and ranges. All right, let's go over some of the examples from last night's homework just to make sure we have a good understanding. So in example number 1, you can see that you have one linear function here and a second linear function right here. So that tells me that my piecewise has its breaking point right here at x equals 0. So what we're going to do is say, okay, the green function represents x values less than or equal to 0. And the purple function represents x values greater than 0. And then what I need to do is I need to find the slope of those functions. So the green one goes up 1, right 1, up 1, right 1, up 1, right 1. So that means its slope is a positive 1. It goes through the origin, so it's kind of like an x plus 0, which is not necessary, but you can write it. The purple function goes up 2 over 1, up 2 over 1. So that means its slope is 2x, and again goes through the origin, so kind of like that plus 0. So your answer for number 1 was x for x values less than or equal to 0, and 2x for x values greater than 0. Now, if you put the equal to with the purple and not with the green, totally fine. Number 2, a little bit trickier because now we have two functions. So once again, we have a green and a purple. The green function and the purple function change at -2. So we're going to say x values less than -2. And then x values greater than or equal to -2. And again, the reason that this one gets the equals is because it has a closed circle up in the graph. Now we need to figure out the slope. So the green line's going up 1, right 1, up 1, right 1 again. So there's a slope of x. But this time, if I keep continuing that pattern, its y-intercept would be up here. So that's 1, 2, 3, 4, 5. So the equation of the green line would be x plus 5. The purple line is a horizontal line. We need to regard that horizontal lines have a slope of 0. So it's going to like a 0x, which again, you don't even need to show me. These are the nice problems in the piecewise that are just a number. So this is at y equals -2. So it would just be a -2. If you really wanted, you could put the 0x -2. But again, not necessary. Same ideas for 3 and 4. I will be posting an answer key to those. And actually, I don't want to post the answer key now because I extend this assignment to give you guys time to ask me questions and to kind of go over questions. So that's why I'm not putting up an answer key to that today. For number 8, my hint is that this is going to consist of a bunch of horizontal lines. So it's going to look like what we call a step function, but basically it's going to look like a bunch of horizontal lines. So again, that's my hint for number 8. And then this is your assignment for today. you're doing the review in our note guide. You are doing the next 2 pages. So the first page is 2.5, the second page is 2.6. So what we're doing in 2.5 is looking at that line of best fit. So in order to get that, you need to use your graphing calculators. So you're going to go on those graphing calculators, and we're just going to walk through those steps real quick. Clear out anything on your screen. You're going to go to Stat, and then Edit. And then you can see I have data in my list, so I'm just going to hit Clear at the top. Clear all that data out. In L1, I'm always going to put the top row. And then in L2, I'm going to put the data from the second row. And then what I'm going to do is exit out of this again, go back to Stat, arrow to Calc, go down to option 4 for linear regression or line equation. So we see that the slope is 5.425. So again, we're not doing the top line right now, we're doing the second line. And then the y-intercept is the b-value, so 76.406. Remember that the r value is not r squared, it's r. So it's 0.7859. That r value is pretty close to 1, not really close. So the type of correlation, because it's positive, is a positive. And I would describe this as pretty strong, but not super strong. So just strong positive. Is the correlation strong? Yes. Use the linear regression equation to predict a student's test score if they studied 4 hours. So remember, hours is x. So we're going to take 4 hours and plug it in for x. So it has to get multiplied by that 5.425 and then add 76.406. And we get a 98.1. So it's predicted they'd get a 98.1% on their test if they studied for 4 hours. Now, line of best fit means drawing by hand. We draw by hand by plotting our points in a scatter plot. So we're going to plot the points in the data. 178, 0.75, 3.90, 1.5, 0.89, 2.75, is a 97, 1 hour is 85, 0.5 is 81, and 2 hours is 80. So again, you can see that there is a correlation. They're definitely going up. The reason it's not super strong is because these points down here, they're kind of like, well, you've studied for a pretty good amount of time, but you still didn't, maybe get the same score as somebody who studied the same amount of time. A line of best fit for each of us might be a little bit different. So what you're going to do is you're going to try to guess what that line might look like. if it tried to average up all those points. So one option might look like that. You know, somebody else might think that that was a little low, so their line might go like this. Pretty close to my first line, a little bit higher. So again, it just kind of depends on you. Now to find the line of best fit, you have to pick points from the line you drew in, not the table. So it looks like, you know, at 0.5 we have this point. So none of my points are super nice. I'm just going to pick, you know, maybe 1 hour because I like nice numbers, and 2 hours. So at 2 hours, it looks like it's at like 91. And at 1 hour, we look like we're at maybe 83. So then my line slope would be 91 minus 83 over 2 minus 1. See why I picked 2 and 1? Now my bottom's 1. So 91 minus 83 is 8. And then what we would do with that is plug it in. So it looks like my y-intercept's 74. So we have y equals 8x plus 74. So if you compared my equation to their equation, my y-intercept's a little lower, but my slope is a lot higher. So I think that students can improve with less study time, basically, is what my graph's saying. And if you were to compare both of those, so if you graph both of those, and again, I'm just plugging it in my calculator so you can kind of see this. Our data is 0 to 4 by 0.5s, and then 60 to 100 by 5s. So you can see the points represent the scatter plot. The first line drawn is the line the calculator got. The second line drawn is my line. So we kind of agree in here, but then I say after so many hours of studying, they're going to do better, where the linear regression on the calculator says not so much. The calculator linear regression is more accurate than mine. It's very precise. So just a comparison of the two, but you can see how what you do by hand compares to what happens in reality. So that is how you do linear regression on the calculator. And that was part of your review for today. The second part is looking at piecewises like we did the other day. So we'll just do number 12 together again. So basically number 12 is a piecewise function with 3 breaking points. Our breaking points are at -4, 0, 3, and 3. So my table has 1, 2, 3, 4, 5, 6, 7, 8, 9 values. So since we have 3 breaking points, we're going to do 3 for each. The first one is x values less than -4. So it's going to be at -4, and x values less than that. So -5 and -6. My second breaking point in the middle there is 0 to 3. So we're going to start it at 0. End it at 3, and pick a number in between, so 1 or 2. And then my third breaking point or graph starts back at 3 again. So we go 3, 4, and 5. The last one's the easiest. That's a horizontal. So this is always 8. Since the inequality is greater than, but not equal to, it's going to be an open circle on my graph at that point. The middle part is linear. It goes open and then closed. At x equals 0, y is 0, 1, and 3. And then the top part of the graph is negative 3x. So that's like negative 18, negative 15, and negative 12. So, unfortunately, I numbered these, and you're not going to ever see this purple part. You could have done one of two things. You could change my numbers, so you could go and see that part of the graph. So maybe instead of by 2s, we go, or instead of by 1s, we go by 2s. So that would be 16, 14, 12, 10, 8, 6, 4, 2, negative 2, negative 4, negative 6, negative 8, negative 10, negative 12, negative 14, negative 16, just so you can see our graph. So if I start at the middle, it's 0, 0, it's open. And at 1, 1, 2, 2, then at 3, 3, it's closed. The second half from 3 on, it's open at 3, 8, but continues forever. So this arrow here matches the inequality there. And then the beginning part of the graph down here at negative 4, negative 12, it is closed. Negative 5, 15, and once again continues forever. So let's talk about its domain and range. This domain is unique. It jumps from negative 4 to 0. So my domain is negative infinity to negative 4, including negative 4, so it gets a bracket. And then 0 to positive infinity. The range are the y values included in the graph. So here, this graph starts at negative 12 and goes down. So it'd be y's less than or equal to negative 12. And then it jumps back up and it goes from 0 to 3. Includes 3 but not 0. And then it picks back up again at 8. So my range can have as many breaking points as my graph. And then this is a function because it would pass the vertical line test. So this is a function. I do want to talk a little bit about your quizzes. So I want to go over some of the results and tricky questions from that with you too before you finish working on this.